We know that SOHCAHTOA can be used to solve for missing sides and angles in a right triangle, along with Pythagorean theorem, which helps you solve for missing sides in a right triangle. Both of these formulas are only used for right triangles, so we need something else for oblique triangles, which are triangles that do not have a right angle. So one formula is the sine law. And before we can get into that, we have to know how to label our triangles properly. So all angles will have uppercase letters, and all sides will be labeled with lowercase letters, but it's important how you label them. So across from angle A is always side A. Across from angle B is side B, and across from angle C is side C. So the labeling is very important. And then our sine law is a ratio. So we have side A divided by sine of angle A equals side B divided by sine of angle B equals side C divided by sine of angle C. Or you can flip it around. It really doesn't matter which way you use the formula. Now you will only use two of those fractions, and then you will cross multiply to solve. Now, in order for you to use sine law, you need to have a full pair and then another side or angle. And what I mean by a full pair is to have an angle with its opposite side. So if I had angle A and side A given to me, that would be a full pair. Or angle B and side B, or angle C and side C. Those are full pairs. So let's try it out. In our first triangle, we are going to be solving for side B. So first thing I want to do is label the side. So across from angle A is little a or side A. Side B is already labeled, and across from angle C is side C. And now I notice that I have full information about A. I have the angle, which is 58, and the side length, which is 6. Now, because I need to solve for side B, I better have angle B to accompany it. So these two are what I'm going to use for my ratio. And now it's time to set it up. So I'm just going to put the sides on the top. So I'll start with A. Side A is 6 and angle A is 58. So I have 6 divided by sine 58. And then I'm looking for side B, and that's going to be all over sine of angle B, which is sine of 75 degrees. Now it's just about cross multiplying. So B gets multiplied by sine 58, and 6 gets multiplied by sine 75. And I don't want you to go to your calculator until the very final step. So here, I need to isolate for B, which means I need to divide both sides by sine 58. And remember, these are attached. And whatever I do to one side, I will do to the other. And now this is what I'm going to plug into my calculator, because on the left, they cross out, and I'm just left with B is approximately equal to. And now I want you to try this out and plug it into your calculator. So I want you to put brackets for your numerator. So open up a bracket, 6 sine 75, close the bracket, and then divide it by sine 58. And you should be able to do this all at once on your calculator. If not, do the numerator and then divide by the denominator. And for sides, I want you to round to 1 decimal. So this will be 6.8 units. And now if you didn't get that when you use your calculator, make sure you're in degree mode and then just try again with the brackets. Just be very careful with them. All right, let's try the next one. And in the next one, we are trying to solve for angle A. And before I begin, I will label all of my sides. So across from angle A is side A, across from angle B is side B, and across from angle C is side C. And now I want to see what full information I have. And I have full information about angle B and side B. And of course, I'm looking for angle A, so I hope I have side A, which I do. So this gives me my second pair for my second ratio. And now we can set it up. So I'm going to put the B information for my first fraction because I have full information about it. So side B is 7, and I'm going to divide by sine of the angle, so sine 75. And then for the next one, I have side A is 6, and I'm going to divide by sine of angle A, which I don't know. So my goal will be to try to isolate for sine A, and we have to keep in mind that whenever we solve for angles, at some point we're probably going to do the sine inverse. But we do have to begin with our cross multiplication. So I have 7 times sine A equals 6 times sine 75. And now I'm going to divide both sides by 7. I can't divide out the sine because that sine is attached to A, so I'm just going to divide out the 7, and that will cancel them out on the left. And then I'm not going to go to my calculator just yet. What I am going to do, I know that I'm going to have to take the sine inverse. So I'm going to take the sine inverse of this entire fraction. And if you can do this all at once in your calculator, that's great. If you want, you can plug in 6 sine 75 in brackets divided by 7, and then take the sine inverse of that. Just don't delete all of those decimals or you will lose accuracy. So if you can, try to use your answer button in your calculator. So personally, what I do, I open up a bracket and type in 6 sine 75, close my bracket, divided by 7, and I get 0.82793642225. I have an answer button on my calculator, so I'm just going to do shift sign, and I click the answer button, and it takes everything with it, so I get approximately 56 degrees when I round to the nearest whole number. But if you can't do that, if you don't have the answer button, just write down at least 4 of those decimals and then take sine inverse of 0.8279, and that should be sufficient. So then we get A is approximately 56 degrees. And that's it. So we wanted to figure out what the full pair was, and that would create one fraction. And then the angular side that we need, that would create our other fraction for the pair. And then it's just about cross multiplying. And I want you to remember that when you're solving for a side, you're cross multiplying and then isolating for that side. However, when you're solving for an angle, you're isolating for sine of the angle so that you can take the sine inverse as your final step. Now, let's try some more. Okay, so for this one, we're looking for angle P. So let's start off by labeling our triangle. So across from angle P is side P, across from angle Q is side Q, and that's the blank one, and across from angle R is side R, which is 12. And now we have full information about R, so we're definitely going to use that. And I'm looking for angle P, and luckily I do have side P, so I'm going to use that. If I didn't have side P and I had information about Q, sometimes you'll have to do an additional step where you solve for a different piece of information first so that it can help you solve for your end goal. So it's not always going to be a one-step thing. So I want you to pause the video here and I want you to try to set up your sine law. And then just once you set up that first initial step, come back, check your work, and then we'll go from there. So hopefully you have 12 over sine 45, and this is our R pair, equals 10 over sine P, and that's our P pair. And now again, I want you to pause the video, cross multiply, and note that you are trying to isolate for sine P so that you can take the sine inverse later to get your actual angle. So pause the video and try it out. Okay. Okay, so we should have 12 sine P equals 10 sine 45. And then you will divide both sides by 12. And when we do that, we know we're going to have to take the sine inverse of this entire fraction. So if you got to this step, that's great. And if you didn't, check to see where you went wrong. Make sure you're not dividing out the 12 and you think you're done and you have P. You have to remember that sine inverse part. And when you plug it into your calculator, you should get approximately 36 degrees. Okay, let's go to the next one where we are solving for side C. So again, I'm going to start off by labeling. Across from angle A is side A, which I don't have any information about. Across from angle B is side B, and across from angle C is side C. So I see I have full information about B, and I'm looking for side C, and luckily I have angle C. So pause the video here, set up your ratio, come back to check your ratio. So our B pair should be 7 over sine 65, and that's going to equal our C pair, so side C over sine 45. And now again, I want you to pause the video, cross multiply here, and then isolate for C to get your side length. And because we are finding a side length, you're not going to have to do any sine inverse at all. So when you cross multiply, we should have C times sine 65 equals 7 times sine 45. And then we'll divide both sides by sine 65, and that will cancel them out on the left. And on the right, this is what you will be plugging into your calculator, hopefully. And if you plug it in correctly, you should get approximately 5.5 units, because I didn't label it in centimeters or anything like that. And that's it for this one. And now let's try our final one. So in this final one, we're trying to solve for angle A. So let's of course start off by labeling everything. Across from angle A is side A, across from angle B is side B, and then 4 is side C. Now, I have full information about C, and my goal is to solve for A, angle A, but I don't have side A. So unfortunately, I can't use A, and I won't get my solution right away. What I do have though is side B. So instead, I'll solve for angle B, and then I know that all three angles are going to add up to 180. So if I know that, once I have angle B, I can get angle A really quickly. So this will require your sine law and then your 180 rule. So I want you to set up your ratios or your sine law for your B and C pair, cross multiply, solve for angle B, and then solve for angle A. And then I want you to come back to the video to check your work. All right, so for our setup, 4 over sine 42 is the C's, equals 5 over sine B. When we cross multiply, we should have the following. 4 times sine B equals 5 times sine 42. And then we can divide both sides by 4, which cancels out the 4's. And then we're going to be taking the sine inverse of that fraction, which you can do all at once or in 2 steps. Just make sure you are keeping at least 4 decimals when you're taking the sine inverse. And now, hopefully for angle B, you got 57 degrees. And now if we have angle B and we know what angle C is, we can find angle A by doing 180, subtract 57, subtract 42 to get 81 degrees for angle A. So this one required 2 steps, but we have to remember that 180 rule. Or also, whenever you're given a triangle and you're given 2 angles, you can always solve for the third one just in case you need it for your sine law. And that's it for your sine law. So you can use it whenever you have a full pair and then one more piece of information. And remember, this is something that you can use for any triangle, but really for those non-right triangles.